Hello everyone, welcome back to class 6 series on my channel Mathify with Meenakshi. In previous video we have covered the first figure it out of chapter 5 prime time. Now let's move ahead and start a very interesting game, a jump jackpot that's on page number 109 of your textbook. Imagine a game where you can only move in equal jumps and there's a hidden treasure waiting for you. Let's see how Jumpy can win this game. So here we have Jumpy and Grumpy and they are playing a game. Grumpy hides a treasure on a number, let's say 24. Now, Jumpy chooses a jump size. If he chooses 4, then he has to jump only on multiples of 4. That means he will keep jumping in equal steps starting from 0. So, Jumpy gets the treasure if he lands on the number where Grumpy placed it. So right now he placed on 24. Now which jump sizes will get Jumpy to land on 24? If he chooses a jump size of 4, then he will land on 4, 8, 12, 16, 20, 24. That means he lands exactly on 24 and gets a treasure. So basically, Jumpy will win only if his jump size divides exactly 24. So all the jump sizes that work for Jumpy are the factors of 24. So you can say successful jump sizes are 2, 3, 6, 8 and 12. As you can see the figure, when he will choose these jump sizes, he will definitely get a treasure. Now on the basis of this game, we have two questions. First, what about the jump sizes of 1 and 24? As here, all the jump sizes are mentioned except 1 and 24. So, what if he will select the jump size as 1 and 24? You know that if he will select the jump size of 1 and 24, yes, he will definitely reach to 24. Why is it so? Because 1 and 24, because 1 and 24 are the factors of 24, or you can say that they divide 24 exactly. Now second question, what jump size can reach both 15 and 30? So I will explain this thing to you. What happened, Grumpy increases the level of the game, like now two treasures are kept on two different numbers, like here 15 and 30. Jumpy has to choose a jump size and stick to it. Jumpy gets the treasure only if he lands on both the numbers with the chosen jump size. As before, Jumpy starts at 0. That means he can't change his jump size. So he have to take both the treasures that's on 15 and 30. So what jump size he will select? You know that if he want the treasure on 15, so the numbers should be factors of 15, and if we want the treasure on 30, the jump size should be factors of 30. But now he wants both the treasures and he have to select the same jump size. That means jump size should be common factors of 15 and 30. And what are the common factors of 15 and 30? 1, 3, 5 and 15. That means Jumpy can select these jump sizes so that he can take both the treasures that are kept at 15 and 30. Now let's move to next question that's given on page number 110. First you have to see this table, and on the basis of this table you have to give answers of these three questions. First, is there anything common among the shaded number? Shaded numbers mean green color numbers. So what is common? Just see the numbers. It is 33, 36, 39, 42, 45, 48 and so on. What you realize that all are multiples of 3. Second part, is there anything common among the circle numbers? So first write the circle numbers, that is 32, 36, 40, 44, 48, 52 and so on. What you realize that all are multiples of 4. Now let's move to third part. Which numbers are both shaded and circled? First let's write those numbers. 36. First is 36, you can see here. Then 48 and then 60. Now they are saying what are these numbers called? If you will see carefully, these numbers are common multiples of 3 and 4. Or you can say that they are multiples of 12. Now let's move to figure it out. That's on page number 110 and 111. Question number 1. Find all multiples of 40 that lies between 310 and 410. So the first multiple after 310 is 320, and then you have to simply plus 40 40, so that's 360, and next is 400. Now let's move to question number 2. Who am I? I'm a number less than 40. First you have to think that numbers less than 40 are 1, 2, 3 up to 39, because they're saying less than 40, so you will not take 40. Then the second hint is one of my factor is 7. Now out of these numbers, whose one of the factor is 7? So you will write numbers whose one of the factor is 7 are 7, 14, 21, 28, and 35. Now the last sentence, the sum of my digits is 8. So out of these numbers, number whose sum of digit is 8 is, you can see, that's 35, because 3 plus 5 is 8, as 3 plus 5 is 8. Now let's move to B part. I'm a number less than 100. So first you will write numbers less than 100 are 1, 2, 3 up to 99. Now, two of my factors are 3 and 5. That means both the numbers are the factor of that number. So you have to write those numbers whose factors are 3 and 5. That means you have to write multiples of 15. So that's 15, 30, 45, 60, 75, and 90. Now they're saying that one of my digit is one more than the other. So this is the answer. You have to see the difference between both the digits. So you will write the answer is number whose one digit is one more than the other is 45. Now let's move to question 3. A number for which the sum of all its factor is equal to twice the number is called a perfect number. That's we have already discussed in previous video. Now they're giving example like 28 is a perfect number. Now they're saying find a perfect number between 1 and 10. As I already told you this thing in previous video, that between 1 and 10 we have a perfect number 6. So you will write a perfect number between 1 and 10 is 6. And why is it so? Because if you will take the sum of all its factors, that is 1 plus 2 plus 3 plus 6, it will give you 12, and that is double of 6. So this implies it's a perfect number. Now let's move to question 4. Find common factors of first part 20 and 28. So first you will write factors of 20. So how will get 20? 1 into 20, 2 into 10, and 4 into 5. So factors of 20 are 1, 2, 4, 5, 10, and 20. Now, how will get 28? So, write all the factors of 28. 1 into 28, 2 into 14, 4 into 7. So, factors of 28 are 1, 2, 4, 7, 14, and 28. So, what are the common factors? You will write common factors is equal to 1 is the common factor, 2 is the common factor, and 4 is the common factor. So you will write 1, 2, and 4. Now let's move to B part. Now I will write the factors of 35. What are the factors of 35? 1, 5, 7, and 35. Now I'm writing directly. And what are the factors of 50? You know, 1 into 50. So 1 and 50. Then 2 into 25. Then 5 into 10. So these are the factors of 50. So you have to write common factors. So what are the common factors? 1, as you can see here, 1 and 5. Now let's move to C part. For C part, first you will write factors of 4. That's 1, 2 and 4. Then factors of 8, 1, 2, 4, 8. And factors of 12, 1, 2, 3, 4, 6 and 12. So again, what are the common factors? So common factors are 1, 2 and 4. 1, 2 and 4. Now let's move to D part. So what are the factors of 5? It's a prime number, so only 1 and 5. 15, it's 1, 3, 5, 15. And for 25, it's 1, 5 and 25. So again, common factors are 1 and 5. 1 and 5. Now let's move to next question, question number 5. Find any three numbers that are multiple of 25 but not the multiples of 50. So first write multiples of 25. What are the multiples of 25? 25, 50, 75, 100, 125, 150, 175, 200 and so on. So these are the multiples of 25. But they're saying that multiples of 25 that are not the multiples of 50. So we will not take multiples of 50. So just cross that. That are the multiples of 50. Now we have to just write three numbers. So your answer is 25, 75 and 125. You can write any three numbers because they didn't wrote that first three numbers. So I wrote 25, 75 and 125. Now let's move to question number 6. Anshu and his friends play the Idli Vada game with two numbers which are smaller than 10. Both the numbers are smaller than 10. The first time anybody says Idli Vada is after 50, that means the common multiple of those two numbers that they have selected for Idli and Vada should be more than 50. So let's make a table that the number selected for Idli, here the number selected for Vada, and here the number that we'll get for Idli Vada. The first common multiple we'll see. Because they're saying first time when someone will say Idli Vada. That means you have to see LCM of Idli and Vada should be more than 50. So you have to select numbers for Idli and Vada that is less than 10 and the LCM should be more than 50. So what do you will do here? Just think for the numbers whose first common multiple, that's LCM, is more than 50. Just think for the numbers whose LCM is more than 50. Our number should be less than 10. So just try to select the numbers that are co-prime and then their product is the LCM. So I will select the numbers like 7 and 8. So the first 7 and 8 are the consecutive numbers and that's why they're co-prime. So directly the first common multiple is the product. You can say 7 into 8, 56. So yes, it satisfies the condition that you will say first time idli vada after 50. Second, you can take 7 and 9. Again, they are co-prime. So LCM is 63. First time you will say idli vada is at 63. And you can take 8 and 9. Again, the numbers are consecutive. That means they are co-prime. And what is 8 into 9? 72. So these are the three possibilities where when you will assign the number for idli and vada and both are less than 10 and on these numbers you will say idli vada after 50. So let's move to question number 7. In the treasure hunting game, Grumpy has kept treasure on 28 and 70. What jump sizes will land on both the numbers? So we just discussed the game jump jackpot. So you have to simply select common factors of both the numbers. So what are the common factors of 28 and 70? I will write what is 28? 1 into 28, 2 into 14 and 4 into 7 and for 70 it's 1 into 70, 2 into 35, 5 into 14 and 7 into 10. So what are the common factors? You see here 1, 2 and 14 and 7. So you will say 1, 2, 7 and 14. These are the jump sizes. If we will choose these jump sizes, then he can take both the treasures that are on 28 and 70. Now let's move to question number 8. In the diagram below, Guna has erased all the numbers except the common multiples. So we can see common multiples, that's 24, 48 and 72. Find out what those numbers could be and fill in the missing numbers in the empty regions. So we have to find, in red circle we can write multiples of what, and in green circles we can write multiples of what, so that the common multiples are 24, 48 and 72. As you can see, in common multiple this is the least common multiple, so that means you have to select two numbers whose LCM is 24. So you can do this in two ways. First, you can select any two co-prime numbers whose product is 24, because then also you will get LCM as 24. So for that you can select 3 and 8. 3 and 8. Because 3 into 8, why only 3 and 8? Because how will get 24? 1 into 24, 2 into 12 and 3 into 8. So out of this, fish pair is co-prime, that's 3 and 8. That's why first is you can directly select the co-prime numbers whose product is LCM. This is first way. So I'm telling you the first way first. So I will write all the numbers till the highest one, that's 72. All the multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24 is there, so leave 24, 27, 30, 33, 36, 39, 42, 45, 48 is there, leave that, 51, 54, 57, 60, 63, 66, 69 and 72 is here. So stop. Now we'll write all the multiples of 8. 8, 16, 24 is here, so we'll not write that. 32, 40, 48 is here, leave that. Then 56 and 64. Now 72 is here, so we'll not write further. Now this is the first answer. Is there any other possibility? Yes. So I will write that too. Second way is that you can select, because you know LCM is 24, so you know that if you will select any factor of 24 with 24, you will always get LCM as 24. As we know that when we have two numbers A and B, and A is a factor of B, then LCM of A and B is always B. So here, if we need LCM as 24, so we can select 24 and it's any factor. So here we have so many answers like 1 and 24, 2 and 24. So you can select all the factors of 24, 3 and 24, 4 and 24, 6 and 24, 8 and 24, 12 and 24. So you can select any two numbers. So if you want to select this as 2 multiples of 2 and this as multiples of 24, so what you will do, that three numbers are already there. So you will write all the numbers that are multiple of 2 like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, you will leave 26, and like this you will write all the number except 24, 48 and 72 till 70. And here you will not write any number because the common numbers are already the part of this circle, 72, 48 and 24. So you can leave it here only, but what I feel the best one is 3 and 8, because then you were writing some numbers here too. So you can just go for first method, that just select the co-prime numbers whose product is the least common multiple. So I have selected 3 and 8 for that. Now let's move to next question. Find the smallest number that is a multiple of all the numbers from 1 to 10 except for 7. So no need to take 7 there. Now you know smallest number that is multiple of all is LCM. So we have to find LCM of 1, 2, 3, 4, 5, 6. Leave 7, then 8, 9, 10. So this they are asking. So let's find the LCM. 1, 2, 3, 4, 5, 6, 8, 9, 10. So first we'll divide by 2. So if any number you can divide by 2, you will divide. Otherwise, you will copy the number as it is. Like we can't divide 1 by 2, so I will write 1 as it is. Here 2 divided by 2 is 1. Then we'll write 3 as it is. Now 4 divided by 2 is 2. then 5, then 3, then 4, then 9, then 5. Again, we have 2 and 4 that we can divide by 2. So you will write again 2. So 1, 1, 3. 2 divided by 2 is 1, 5, 3. 4 divided by 2 is 2, then 9 and 5 as it is. Again, we have one more 2, so we'll write 2 again. But all the numbers you have to copy as it is because we can't divide them by 2. Just write 1 here because 2 divided by 2 is 1. Now, next prime number you can take 3 because you can divide the numbers by 3. So 1, 1. 3 divided by 3 is 1, 1. You will copy 5 as it is. 3 divided by 3 is 1, 1. 9 divided by 3 is 3, then 5. Again, you will write 3 because we have one number here 3. 1, 1, 1, 1, 5, 1, 1. 3 divided by 3 is 1, 5. Now you will divide it by 5 because only prime number that we're left with is 5. So let's divide all the numbers by 5. You will only divide those numbers that are divisible by 5. Rest you will write as it is. So now what is the LCM? You have to just multiply all the numbers that are on the left to get the LCM. That means this LCM is 2 into 2 into 2 into 3 into 3 into 5. Now just multiply 2 into 2 into 2 is 8. 3 into 3 is 9 and 5. 8 into 9 is 72 into 5, that's 360. Even you can multiply that directly like 2 into 2 is 4, 4 into 2 is 8, 8 into 3 is 24, 24 into 3 is 72 and 72 into 5 is 360. I just wrote steps to explain this to you. Now at the end you will write hence 360 is the smallest number that is a multiple of all the numbers from 1 to 10 except 7. Now let's move to last question of this figure it out, question number 10. It's exactly same like question number 9, but here they are saying you have to find the multiple of all the numbers from 1 to 10. Again, the smallest number, that means LCM. So this time you will take 7, 2. So LCM of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's find that. Again, first you will divide by 2. So the numbers that you can divide by 2, you will only divide those numbers and rest you will write as it is. Again you will divide by 2. Again you will divide by 2. Now you will divide by 3. It's exactly same like question number 9. Just 7 is extra here. Now you will divide again by 3. So you will copy all the numbers as it is except 3 because 3 divided by 3 is 1. Now you will divide by 5. 5 divided by 5 is 1. And here also 5 divided by 5 is 1. Now you will divide by 7. So we'll write all ones. And once we have all ones, that's it. So to get the LCM, you have to simply multiply the left numbers. That is 3 times 2, 2 times 3, 1 times 5 and 1 times 7. So till here, so we have already found that's it's 360. So 360 into 7 and that is 2520. So you will write at last, hence 2520 is the smallest number that is a multiple of all the numbers from 1 to 10. Now let's move to last topic, that's sieve of Eratosthenes. By this method you can find all the prime numbers, but right now I will show you how you can find prime numbers between 1 to 100. So first step, you have to cross out 1. That's already marked here. Why? Because it is neither a prime nor a composite. Then you have to circle 2 and cross out all the multiples of 2, that is 4, 6, 8 till 100. Third step, you will find that the next uncrossed number is 3. So you will circle that and again you will repeat the same process. You will cross all the multiples of 3 like 6, 9, 12, and if it's already crossed, it's okay. You can just move further. Now step 4, the next uncrossed number is 5. Again you will circle 5 and cross all the multiples of 5, and again if it's crossed, then leave that number and move ahead. The last step is, when you will do this, you will realize that continuing this process till all the numbers in the list are either circled or crossed out. So all the circled numbers are prime numbers and all the cross out numbers other than 1 are composite number. And as I told you, this method is called the sieve of Eratosthenes method, and this procedure can be carried on for numbers greater than 100 too. So that's all for today's video, and we'll continue this chapter in next video. If you found this video helpful, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Thank you everyone.